Hi all, welcome you all to this new video. In this video, we will continue our discussion on the Unit 1 fluid power principles and hydraulic pumps. So of the syllabus fluid power systems and industrial automation. So the first slide it shows about the recap of the previous sessions. So we studied about gear pumps and vane pumps. So in this session we will understand the construction principles and working principles and the applications of lobe pumps and screw pumps. So these pumps are widely used where a smooth and continuous flow is required. So these are the places where we will use the lobe pump and a screw pump in the industrial applications. So positive displacement pumps such as Lobe and screw pumps are extensively used in these industrial applications. So these industrial applications include hydraulic systems, lubrication systems, chemical processing industries, food processing industries, and the places where high viscosity fluids are handled. There we'll be using the gear pumps and lobe pumps, and the ability to deliver a constant flow rate independent of pressure makes them suitable for these precise applications. So in this slide we are seeing the image of a lobe pump. So let us first discuss what is a lobe pump. Lobe pump is also a positive displacement rotary pump. It uses two or more lobes rotating inside the casing. The lobes do not overcome in contact with each other. It reduces wear, so and it allows the pump to handle sensitive fluids. So that is the major difference of a lobe pump and a gear pump. In other operations, it works exactly as a gear pump. Then the lobe pump working principle is shown here. As the lobe rotates, the fluid is trapped between the lobes of the pump and casing. When the lobes are unmeshed, the inlet side, the vacuum is created, allowing the fluid to enter the pump. Then the trapped fluid is carried along around the casing and discharged when the lobes mesh again. So as I said earlier, it is exactly like a external gear pump working, but the lobes do not mesh with both. So that is the major reason why lobe pumps are capable to handle high viscosity fluids, and it is much quieter in operations. So the next slide we are moving to screw pump. So we move to the screw pump. It is an axial flow displacement pump. So previously we saw it is a rotary option. Now it is an axial flow. That is the fluid will be discharged along the axis of the screw. It is also a positive displacement pump, and I hope you can recollect that all positive displacement pumps have fixed discharge value. It rotates screws move fluid along the axis of the pump. It's smooth and continuous. Screw pumps construction and advantages is shown here. So the typical screw pumps, three precision ground screws, one central power rotor, and symmetrically opposite idle rotors. The idlers rotate seals, that is rolling in contact with the central rotor. These rotors are driven by the pressure of the liquid itself. So only that liquid pressure directly rotates the rotors. Screw pumps deliver a non-pulsating flow, operate very quietly and highly efficient. So they can operate at pressures up to 250 bars. So at that pressure range, it can operate, and a discharge of around 1000 cubic centimeters per minute. The major advantages of screw pumps is that it is highly reliable, pulsation-free oil supply, and the absence of turbulence and very quieter operations makes it suitable. Okay, so this slide we are having a pump type and characteristics. It is summarized here. It is just rearranged for a quiz manner, and you can see the answers also. But let us try to uh, match all the characteristics of the basic pumps. The first, external gear pumps, it operates at high speeds. Then internal gear pumps, it is suitable for high viscosity fluid at moderate pressures. Then for the unbalanced vane pump, eccentric rotor with a spring-loaded vanes are used. For a balanced vane pump, two inlet output ports are opposite to each other. For an axial piston pump, it is the swash plates rotates and a high pressure can be used, and 95% of volumetric efficiency can also be achieved. For a screw pump, axial flow, pulsation free and quiet up to 250 bars of pressure can be used. So understanding these characteristics helps everyone to select the right pump for the given application. So that is the major reason. Then we are having a summary on the gear pumps. So to summarize, the gear pumps are simple, inexpensive, and widely used in all the fluid power systems. However, their efficiency reduces with wear, and they also require high maintenance compared to low pumped screw pumps. Each pump type has its own advantages, and the choice depends on the system requirements. Okay, now if you